everyone, and welcome to another episode of STEM in Seconds. Today I'm going to talk to you about graph transformations and the 6 primary ones you need to know for GCSE. So here is my example graph. It's just a basic quadratic and we're going to give it the equation of y equals f of x. Now this means any function of x, so f of x could equal something like x squared, or it could equal something like x cubed plus 4x squared minus 1 over x. Either way, f of x just refers to a function of x. To transform this graph, I will change this equation. In this first example, I'm going to take the graph y equals f of x, which is this graph, and change it. So I'm now looking at the graph y equals f of x plus a. As you can see, this equation is different to this one, so the graph is going to look a little different as well. What this equation tells us is how the y-coordinate relates to the input of the x. In this case, the input of this x is the same, so f of x yields the same number as it did in this equation, but you then take this number and add a, which means that every point on your graph shifts up by a. So the y-coordinate of this point is now a rather than 0. The other option for adding, again if I take my y equals f of x, is you can add this a inside the brackets, leaving you y equals f of x plus a. If it is inside the brackets, this graph will shift to the left along the x-axis, so we will end up here. But in this case, this x-coordinate will be minus a, because your x does the opposite to what you want. So in this case, this x plus a causes a translation in the negative direction. The second type of graph transformation is if you have a multiplier in your equation. So my initial equation of y equals f of x, I'm going to change the way this graph looks just for a bit of fun, and it's now going to look like that. So this is a cubic graph, but that's not important. The first change I'm going to make is y equals a lots of f of x. And this will cause a stretch in the vertical direction. Again, because this f of x has the same output as this f of x, the only difference between this y and that y coordinate is this multiplier a. If we let this local maximum be minus 1, 2, and this local minimum, 2, 1, I take the y coordinate here, which is 2, and multiply it by a. And then if I let a equal a set number, so y equals 2 f of x, I take this y-coordinate and multiply it by this coefficient. So my new local maximum is at minus 1, 4. And my new local minimum is at 2, 2. So I get a graph that looks like that. The other option for multiplication is that the coefficient is inside the bracket. So y equals f of 2x. If I rewrite my original y equals f of x over here, and let f of x just equal something like that with a minimum point at 3. This is inside the brackets. Now remember what I said earlier, your x does the opposite of what you want them to do. So the graph for f of 2x is a stretch along the x-axis, but of a factor 1 over 2. So in fact, this 3 will become a 1.5. The graph is squished towards the y-axis. The way to always remember which way it goes, if your a is inside the brackets, you will be going horizontally. If your a is outside the brackets, the transformation will take place vertically. So here again is my y equals f of x, which is just a quadratic with a minimum point at 1. I'm going to start with outside the bracket, y equals minus f of x. As I said before, This f of x and this f of x are the same number. So at this minimum point, f of x is 0, and minus 0 is still 0, so your y is still 0. But if I take a point over here, and let's just imagine this height is 3, f of x is 3, which means that this y would be minus 3. So I know the graph does this. The other option is, of course, to have the negative inside the brackets, so y equals f of minus x. Some of you will probably have guessed by now. That's all for this video. Please comment down below if you have any ideas and don't forget to subscribe.